In this video, I'm going to try to help understand the reference cell and what it means. So in the reduction half reaction table, there is a list of electrical potentials. The table is set up, and we've done this before, where the strongest oxidizing agent goes to the weakest oxidizing agent, and the strongest reducing agent goes to the weakest reducing agent. But you also notice that for these reduction half reactions, so reading this way, this electrical potential goes from most positive down to, at the bottom, it goes to the most negative. And so the values that are there are all in reference to the reference cell. And the reference cell in this table is at 0 volts. And so the way that they do that is they construct a variety of cells using hydrogen as the anode. So the hydrogen at the anode is going to go this way. And so if we took, say, iodine and hydrogen as a cell, the E cell equals E cath minus E anode. And if I take those values, I'm going to have the E cell is going to have the positive 0.54 volts minus 0.00 volts. And that's actually how they calculate this value. They use the E cell and have this value set at 0. So if they construct an experimental cell with hydrogen as the anode, it will give the value of 0.54 volts, and it's positive. Whereas if they had hydrogen as the anode and they had nickel 2 as the cathode, its E cell would equal negative 0.26 volts minus 0.00 volts. So this is going to give us negative 0.26 volts. So all of the values that we see written here are written in reference to this being our anode. And so the anode, the reference cell, is how they calculate those values. So there are two kinds of questions that come up for this. The first kind of question is where they're talking about a half reaction. So they say, if we change the reference cell to be, say, let's clear some of this garbage out of the way here. If we change the reference cell to the cobalt half reaction, then this would become my 0.00 volts, right? And all of the values would change by 0.28 volts because now this is our 0. But if they said, what's the new reduction potential for the silver half reaction? They're saying this is my cathode and now this is my anode, and the E cell that I would calculate for that would have positive 0.80 volts, so that's my cathode, minus my anode of minus negative 0.28 volts. And so this would be positive 1.06 volts. Well, that's the difference between here and here, right? That's our cell potential. But now they're saying this number would no longer be 1.80. If this is my 0 value, this becomes positive 1.06 volts. Because if I change my reference cell, all of the other half reactions are going to have new voltage potentials. And the thing that I haven't mentioned is that they just chose the hydrogen cell as the reference cell. So it could be any cell realistically, but they chose the reference cell to be hydrogen. So one sort of question is, what's the new reduction potential for this half reaction? And then what all you do is so this is exactly the question we do. You do E cell equals E cath minus E anode. And now my anode that I've used, so let's say that we change the reference cell to become, I don't know, let's say cadmium and here. So that's my new reference cell. This is my anode. That's the value that I'll use here. And the other half reaction, whatever they say what is the new reduction potential of the iodine cell. This is my cathode. So I would have the positive 0.54 volts minus the negative 0.40 volts. The E cell is going to be positive 0.94 volts. And if this becomes a 0, then this would become positive 0.94 volts. So that's like the standard question with reference cells. The other question is kind of a, do you understand that cell potential is just the difference between the two values? So what they're going to say is something like this. Oh, you've got a silver and lead sulfate cell. So you've got a silver ions as my cathode and my lead sulfate as my anode. So what if I change the reference cell now to zinc? So zinc now is 0.00 volts. What is the cell potential for this particular cell? Well, it's going to be the same no matter what. Where the reference cell doesn't matter. To calculate the E cell for this, I'm still going to go E cath minus E anode. And so I'm going to have the positive 0.80 volts minus my negative 0.36 volts. And the cell potential is going to be positive 1.16 volts. And so this is my new reference cell, but who cares? The cell potential for this whole cell doesn't matter where the reference cell is. Just do the regular calculation, and they just changed where 0 is on the number line, right? This number line, the 0's here, they changed the 0 to here, but the difference between this and this is the same distance, same amount. So that's how you deal with reference cells. The two kinds of questions are, we've changed the reference cell to a different thing. What's the reduction potential for this half reaction? You calculate the cell potential, and then that's going to be the new cathode's reduction potential. Or we changed the reference cell. Now what's the potential of the whole cell, which is going to be the same no matter where the reference cell is, just calculate it the normal way.